Hello everyone, welcome to Navigating with Special Maths Academy. It's been a while. We had a video, and first of all, I would like to congratulate all the students that did well in the Special Maths contest second round that was just concluded recently. I hope you go on to achieve more feats in mathematics. We hope to see you at the top. Also, to those who didn't do so well, it's not the end of the road. You can always go back, work harder, and come back stronger. Okay, so let's look at the question for today. It says, let ABC, so we're looking at the 23rd problem from the Special Maths Contest 2023, the first round. And it says, let ABC be positive real numbers such that A plus B plus C is equals to 5 and 1 over A plus 1 over B plus 1 over C is equals to 2. The range of possible values of C is the real number interval EF. So find the value F minus A. So we want to find the length of this interval. Okay, so let's say we have A plus B. So I'm going to rewrite this equation as A plus B equals to 5 minus C and 1 over A plus 1 over B equals to 2 minus 1 over C. Okay. So the idea is we want to treat C as a constant. Okay. We want to treat C as a constant. But before I go on with this question, I want to just establish some things. So first of all, we're dealing with positive real numbers. Okay. And we want A plus B plus C to be equal to 5. So that means that each of A, B, and C must be less than, okay, strictly less than 5. Okay, it's because of positive real numbers. And I also have 1 over A plus 1 over B plus 1 over C is equal to 2. So that means each of 1 over A, 1 over B, 1 over C must be less than 2. So that implies 1 over 2 must be less than A, B, and C. Okay, so basically it means we have A, B, and C are in the range half and 5. At least this is a weak bound. Okay, so this might come in handy sometime in the future. So now the idea is that we're going to treat C as a constant and want to see what values of this constant produces real, possible real values for A and B. Okay, so we're going to solve for. I'm going to make a. I'm going to like solve it like a simultaneous equation. And so the first thing we're going to do is, okay, so we have B is equals to 5 minus C minus A. Okay, so I'll scroll down a bit. So that implies that we have 1 over A plus, so we put this for B, 1 over 5 minus C minus A. So remember, I'm kind of treating MC like a constant. Is equals to 2 minus 1 over C. Okay, so we can multiply through by 5 minus C minus A times A. Okay, so that gives us what? We have 5 minus C minus A. So plus A equals to 2 minus 1 over C into A into 5 minus C minus A. Okay, so let me scroll down again. So what do we have here? We have minus A plus A, so that cancels out basically. We have 5 minus C is equal to, so here we have A into 5 minus C times 2 minus 1 over C. And then we have minus A squared into 2 minus 1 over C. Okay, so we can kind of create a quadratic equation in terms of A. So I'm going to take this to the left hand side. So we have A squared, and this is the coefficient of A squared. Okay, then we have minus A, and this is the coefficient of minus A. And then we have 5 minus C, so it's just positive. Okay, so now recall, for a random quadratic equation, we have AX squared plus BX plus C equals to 0. For the roots of this quadratic equation to be real, then we need b squared minus 4ac. So the discriminant, we need it to be greater than or equal to 0. Okay. So for the root of the quadratic equation to be real, we need the discriminant to be greater than or equal to 0. So here, let's calculate the discriminant. So recall that if you can get a to be real, then automatically b has to be real because so because we have c, if we pick c to be a real number, right? So c to be any real number, and then we get the conditions that makes a real number. Automatically, b will have to be a real number because it will just be the difference of two real numbers. Okay. So that's just the idea. So we have b squared. So that's going to be 5 minus c to 2 minus 1 over c, b squared. So I can just do it like this because when you take minus this all squared, it just changes to plus. So then minus 4ac. So this is minus 4 into 5 minus c, 2 minus 1 over c. So this one is greater than or equal to 0. Okay. So we can multiply through by c squared. So recall, we already have a bound. So none of these numbers is, even close to 0, right? So it's between half and 5. Okay, so between half and 5, we have a bound. So we can multiply through by c squared. Okay, we're not, of course, c cannot be 0. So yeah, let's just multiply through by c squared. So that will give us to become 5 minus c into 2c minus 1. So I say c squared because we're multiplying this part twice. Okay, so this will now become 4c into 5 minus c into 2c minus 1 greater than or equal to 0. Okay. Okay, so we can factor out 5 minus c into 2c minus 1. Okay. So we have 5 minus c into 2c minus 1. Okay. And then we left with 5 minus c into 2c minus 1 minus 4c. Okay, which is greater than or equal to 0. So we can expand this out. Okay, so 5 times 2c, that is 10c. 5 times minus 1 minus 5 minus c times 2c minus 2c squared minus c times minus 1 plus c, then minus 4c, greater than or equals to 0. Okay. So let's scroll down a bit. Yeah, lots of algebra here. So 5 minus c, 2c minus 1. And then we have so minus 2c squared. And so 10c plus 10c minus 4c. Okay, so this is going to be plus 7c. So 10c minus 4c, 6c plus c, that is 7c. And then we have minus 5. Okay, is greater than or equal to 0. So we can multiply this by minus 1 and this by minus 1. So the inequality sign does not change. So we have c minus 5, 2c minus 1 to be 2c squared minus 7c plus 5. So we can actually factorize this. So 2c squared, so minus 7c can break it down to minus 5c minus 2c plus 5. So we have c into 2c minus 5 and then minus 2c minus 5. So we have c minus 1 into 2c minus 5. Okay. So basically we have, let me scroll up a bit, c minus 5, 2c minus 1, c minus 1, 2c minus 5, greater than or equal to 0. Okay. So now, the good thing is that here we have the coefficient of c in each of these brackets is going to be positive. Okay. Coefficient of c in each of these brackets is going to be a positive number. So now we can analyze this polynomial on the left-hand side of this inequality. So let's just, take a step out of the inequality. And then if we analyze the polynomial, so we have, what are the roots? We have 5 over 2, 1, half. Okay, so we have 4 roots. Okay. Now, if a value is bigger than 5, okay, this will be positive, this will be positive, this will be positive, this will be positive. So it's always going to be positive. Okay. So if the value is in between, the value is in between 5 over 2 and 5. Okay. So this will be negative. This will be positive, this will be positive, this will be positive. Okay. So this is going to be negative. Going to be negative in this interval. The value is in between 1 and values in between 1 and 5 over 2. This is going to be negative. So this will be negative. This will be positive. This will be positive. So this is going to be positive here. Okay, so you get the idea. So I'm just going to, yeah. This is going to be negative. This is going to be positive. Okay. So recall we want positive real numbers, and recall that we said that each of the numbers are in between half and 5. Okay, we want positive real numbers. So the fact that they are in between half and 5 means this region is invalid. This region is invalid. I want positive real numbers, so this region is invalid, this region is invalid. Okay, so it means C must be in the range 1 and 5 over 2. Okay, now the length of that range is going to be what? 5 over 2 minus 1, which is equals to what? 3 over 2. Okay, so let's scroll up and look for our answer. So that is option C, 3 over 2. I hope you learned something new from this video. Don't forget to like, share, comment, and subscribe. Once again, congratulations to all the SMC second round participants. You guys did a wonderful job. Your solutions were actually awesome. So see you in the next video. Stay tuned. Goodbye.